we've talked about linear systems and how to solve them, let's look at what might be able to go wrong. There are two potential problems that we might see. The first, part of this process is to use the second equation to get rid of x2 in the rest of the equations. But what if there's not an x2 in the second equation? Or not an x3 in the third equation? So the real solution to this problem right here is that the order I wrote down the equations in doesn't matter. So let's look at an example to see what we mean by that. We start by using the x1 in the first equation, so we're going to leave the first equation alone. For the second equation, we're going to add the first and the second equation. So x1 minus x1 is 0, 2x2 minus 2x2 is 0, 4x3 minus 2x3 is 2x3, x4 plus 0 is x4, and 0 plus 1 is 1. Next, we'll multiply the first equation by 2 and add it to the third equation. So we have 2x1 minus 2x1 is 0. 4x2 minus 4x2 is 0. 8x3 plus 2x3 is 10x3. And 2x4 plus 2x4 is 4x4. 0 plus 4 is 4. Finally, we'll subtract the first equation from the second equation. Negative x1 plus x1 is 0. Negative 2x2 plus x4 is 2x2. Negative 4x3 plus 2x3 is negative 2x3. Negative x4 plus 0 is negative x4. And 0 plus negative 3 is negative 3. We now want to use x2 in the second equation, but there's not an x2 in the second equation. So instead, I'm just going to reorder these equations so that there is an x2 in the second equation. So I just moved that last equation up to the second equation. We now want to use this to eliminate the rest of the x2s. So we'll leave the second equation alone right now. We'll subtract the second equation from the first equation. So we have 0 plus x1 is x1. Negative 2x2 plus 2x2 is 0. Positive 2x3 plus 4x3 is 6x3. Positive x4 plus x4 is 2x4. And 3 plus 0 is 3. For my other two equations, they already don't have an x2 in them. Now that we have that, we'll use the x3 in the third equation to get the rest of them to be 0. Therefore, the third equation will stay the way it is. I can multiply that third equation by negative 3 and add it to the first equation. When I do that, I end up with x1 plus 0 to get x1. I then have negative 6x3 plus 6x3 to get 0. Negative 3x4 plus 2x4 to get negative x4. And then negative 3 plus 3 to get 0. For the second equation, I'm just going to add the second and third equations. When I do that, the x3s and the x4s cancel. I'm left with 2x2 equal to negative 2. I'll then multiply the third equation by negative 5 and add it to the fourth equation. When I do, I get negative x4 equal to negative 1. Finally, we can start working on the x4 variable. We know our x4 line is our fourth equation is going to stay the same. We can then add the third and fourth equations. When I do, I get 2x3 equal to 0. My second equation can stay the way it is. And I can add my first equation to the negative of my second equation. So do the first equation minus the fourth equation, which would give me x1 equal to 1. So now I have a solution. The first equation says x1 is equal to 1. 2x2 equal to negative 2 gives me a negative 1. 2x3 equal to 0 tells me x3 is equal to 0. And negative x4 equal to negative 1 tells me x4 is equal to 1. So I was able to just switch the equations around. My next potential problem comes from, what if I can't just switch equations around? What if x2 doesn't occur in any of the subsequent equations? Or what if x3 doesn't happen in any of the subsequent equations, etc.? So let's see what happens there. Well, here I have a system of equations. Let's solve it and see what happens. We'll start by letting the first equation stay the way it is. For the second equation, we'll do the second equation minus the first. 2x1 minus 2x1 is 0. Negative 4x2 minus 4x2 is 0. Negative x3 plus 0 is negative x3. And negative 8 plus 6 is negative 2. I'm then going to multiply the first equation by 2 and add it to the third equation. So that would be 4x1 minus 4x1 is 0. 8x2 minus 8x2 is 0. 2 times x3 is 2x3 plus x3 is 3x3. And 2 times 8 is 16 minus 10 is 6. We see that we can no longer eliminate variables here. We cannot eliminate x2. It's absent from both the second and third equations. So instead, I'm going to use the second equation to get rid of the x3s. We have negative 3x3 equal to negative 2. I'm going to add the first and second equations. When I do, the x3s will cancel. I get 2x1 plus 4x2 equal to 6. And then I can multiply the second row by 3 and add it to the third equation. And when I do, I get 0 equal to 0. So the question is, how do we actually interpret this? Our final equation doesn't give us all of our information, but it does give us some. Our second equation tells us that x3 is equal to 2. But we also know a little bit more than that. If I take this first equation and solve it for x1, I get that x1 is equal to 3 minus 2s. And then we don't have any additional information about x2. So traditionally, we call this a free variable, meaning that it can be any value. x2 can be absolutely any value. And then we can use that to determine what x1 needs to be. We tend to write this by introducing what's called a parameter. So essentially, we let x2 be equal to s, where s can be any real number. Then x1 is 3 minus 2s, x2 is s, and x3 is 2. Let's try one more. So here I have my system of equations. I want to use the first equation to eliminate x1. The first equation will be left alone. We then multiply the first equation by negative 2 and add it to the second equation. When we do that, we get negative x4 equal to 1. We'll multiply the first equation by negative 3 and add it to the third equation. We get 3x4 equal to negative 3. And finally, multiplying the first equation by negative 4 and adding it to the fourth equation gives us 0 equal to 0. Now, both the x2 and x3 are absent from all the subsequent equations, so we're going to move on to x4. We'll use the second equation to eliminate all of the x4s. My second equation won't change. It'll be negative x4 equal to 1. And my fourth equation says 0 equal to 0. It's a redundancy equation, so we can go ahead and write that down. I'll multiply the second equation by 2 and add it to the first equation. I get x1 minus x2 plus 2x3 equal to 2. And then multiplying the second equation by 3 and adding it to the third equation gives me another 0 equal to 0. So we solve that first equation for x1. That gives us that x1 is equal to 2 plus x2 minus 2x3. We can also solve the second equation. It tells us that x4 is equal to negative 1. So we can't say anything about either x2 or x3. So they're both going to be free variables. We'll represent one with an s and one with a t. Therefore, we write x1 equal to 2 plus s minus 2t, x2 equal to s, x3 equal to t, and x4 equal to negative 1, where s and t can be any real numbers.